Okay, now let's go to a more complicated application, the SARS. Well, if you are around your 20s, you may remember a little bit about this terrible news. In 2003, the SARS broke out from Hong Kong, China, to the whole world, and it stands for Severe Acute Respiratory Syndrome. And a few months later, 4 months later, the WHO, the World Health Organization, identified 812 people died. And the cost is tremendous. Just one airport in Canada cost $30 million a day just to do the quarantine to the people. So that's an interesting question, because we have all the epidemiological information. So we can do the research to simulate the problem. Now, what's the assumption? Well, in the beginning we talked, different disease will result in different model because different assumptions. Well, we all have no birth in the assumption. The difference clearly is you have to consider the death. In the previous model, we assume is so weak, there's no death. And the second, because the policy, we introduced the quarantine, and then we needed to divide the susceptible population into subgroups of those who are quarantined and those who are in the isolated community, and so on and so forth. And the fifth assumption, we assume the quarantine and isolation is completely effective. So someone who has the disease and is in the quarantine or isolated community cannot spread the disease. That's what you do with the quarantine. Well, with all those assumptions, we no longer have only 3 variables. Instead, we're going to have 9 unknown functions. And these 9 unknown functions have the same group recovered. That's the same, the easy one first. And the susceptible, that's the same. But in the original population, we needed to add 3 groups of quarantined people. The first group are the individuals, they're in the quarantine, but does not have the SARS. And the second, and they have exposed to the SARS. They have SARS, but no symptom, so not yet infectious. The third, they have the SARS, no symptom, but is infectious, and it's quarantined. So even in the quarantined group, there are 3 subgroups. One is with no disease, another one is those who has the SARS, but not yet infectious. The third one is have the disease, also infectious. For the infected people, we also have 3 groups now. The first group is the same. It's infectious but undetected. That's the dangerous group. That's the only group that really spread the SARS. Another 2 groups, the infected, quarantined, they're safe now for the other people. And the third part, They are infectious, but in the isolated, they are not traveling, and in an isolated community, they're not going to hurt other people. So the last one, which is the new one, you need to introduce the death due to the SARS. So after you add all the groups, we can count, we totally have 9 variables instead of 3. But the basic idea is still follow to the SIR model, and then probably you call it SIRD, death. Because the quarantined people have no harm, just like inoculation. So S, this is the only group could be infected. Infected undetected is the only people spread the disease. And the recovered is the same as the old model, but you need to add the death rate. And then 3 quarantined group and 2 more quarantined infected group. So in this conceptual model, I will let you read the detail. So basically, the conceptual model is what I talked a moment ago. As soon the quarantine is completely effective, then only the susceptible, the first group, spread the disease. And then infected group, only those who has not been detected and has contact to other people spread the disease. And now let's look at the conceptual model. And we're not going to analyze all the detail. There's a homework in the project. You can simulate and run by yourself, observe, and answer the questions. So it takes time to really know the detail. But let's look at the conceptual model. This is the group have the potential to become infected. So we add another one is called exposed. And then this is susceptible, a part of it become quarantined. And I'm not going to go to all the details. Only this group, the infectious undetected contact with the susceptible could make the people either become infectious in the isolated community or in the end become death, or it could be recovered. Where's the recovered? Okay, here's go. Here's recovered. So that's the baseline. And then you look at all the other population. That's how you split the populations. Well, if you follow the conceptual model and understand the baseline idea, it's not that complicated. Finally, let's see what we can do. You will see that is a model. It's really unrealistic because people are different from people, and the contact have different contacts. Sometimes you have a contact in the close distance and the more density of the population. Sometimes it's very casual, far distance contact. Regardless of how unrealistic, the model served a very good purpose in the beginning to help the WHO to realize the danger of this disease. And so the officers in different countries paid attention, invested the money on time and the content in a few months. And what's the worst case? Nobody can predict. But if had done nothing, it definitely would be a terrible catastrophe. And so the model served the purpose to remind the people, you got a dangerous disease, you got to do something, pay the money, and on time. All right, so this is for today. To really learn how to use this model to solve real-world problem, you start with the exercise first. And then it's your choice. You could do a nice team project in that direction. So we can discuss this individually. Thank you. I will see you next time.